Hi everyone. What I wanted to do with this little video right now, and this is going to be the first of a whole bunch of them that we'll go through for your math course. But this one in particular is going to be talking about uh, sets of numbers and why that's important. So, a couple of things that we want to keep an eye on first with our sets of numbers. The very first thing is that we need to know what our numbers are and what we're kind of referring to as these sets of numbers. So the ones that I'm going to be concentrating most on are going to be the set n, which is natural numbers. That's your counting numbers. So those numbers go 1, 2, 3, 4, and they keep going on up. They're all whole numbers. Notice there's no negative numbers and there's no zero. That's actually very important. The next set of numbers we're going to look at is integers. For some reason, the set terminology for that is a z instead of an I, and that incorporates all of the natural numbers. It also incorporates the negative of all the natural numbers and zero. So all your integers, all your whole numbers, both negative, positive, and including zero. Q, that's your rational numbers. What that means is the Q comes from a quotient, or the whole numerator divisor thing, from when you're dividing. So that means any expression that can be created by taking two integers and dividing them into each other, provided that the denominator is not zero, will cover that for us. And then the final one is your real numbers. That's the ones that you'll be dealing with most of the time. So anything that can be shown as a decimal is a real number. There are other sets out there that incorporate other numbers that don't fall inside of here, but for how we're concerned, this is what we're really interested in. So now that we have that done, what we want to do is we're going to go through some examples of just determining which sets do a particular number belong to. So we're going to start off with the number 3. So where does 3 go? Well, let's just go through our list. We have natural numbers. Is 3 a natural number? Well, is it a whole number? Yes. Is it a counting number? So is it 1, 2, 3 on up to whatever number you want to go to? Yes, it is. So 3 is going to belong to the set of natural numbers. Now, because it belongs to the set of natural numbers, it'll also belong to all the other sets. So it's also going to belong to integers, quotients, and real numbers. If we take a look at minus 5, for example, well, is minus 5 a natural number? No, it's not, because it's negative. So we can eliminate it from there. Is it an integer? Yes, it is an integer. So it belongs to Z. It's going to belong, because it belongs to Z, it automatically belongs to Q and to R. Now, we'll get into some kind of quirky ones. The square root of 4. When you initially look at that, you're going to say, well, that's not a real number. But yeah, it is. The square root of 4 is actually 2. And it's because the square root of 4 is 2, 2 is an integer. Therefore, it belongs to integers, quotients, and real numbers. How about 0? Well, guess what? You'll think 0 is a natural number because it's 0. We always use 0 for all kinds of stuff. But no, it's not a natural number. It's actually an integer, because your natural numbers start at 1. You don't count things generally we don't count things 0, 1, 2, 3. We count them 1, 2, 3. So that's why that's like that. Okay, now we'll have 24 divided by 3. Well, what'll that be? It's quite obvious. It's definitely going to be at least a quotient. or a rational number because it's two integers being divided by each other. But in this particular case, it is actually an integer. The answer is 8. So again, it's still a member of all of these. Alright, give me 1 second here. Now, how about the number 1.0? Now, everyone's going to say, hey, that's 1. That's an integer. But in this case, because this decimal is actually there, this one is really only going to belong to our real numbers. If you were to say it was an integer, I'm probably not going to mark it wrong unless I'm specifically looking for something. But in the broadest sense of the term, that one is only a real number. So 9 over 2. Well, when we do our division of our 9 over 2, do we get an integer? No, we get 4.5. So that means that 9.2 can't be an integer, but it's definitely a rational number because we got an integer 9 divided by another integer 2, and the bottom integer is not 0. So we've met our rules. And because it's in this set, it's also a member of real numbers. How about the number 18? Well, the number 18, it's a counting number. It's not one of the early ones, but it's kind of up there. So because it's a counting number, it's a whole number, and it's greater than 0. So it's 1 or higher. Therefore, that one's going to be a natural number. It's going to also be an integer. Now you might wonder why we call it a quotient, but if we divide it by 1, it makes it into a quotient. So it kind of falls into all sets that way. And now let's go with the square root of 2. So now you look at this one and you think, well, we did the square root of 4 a minute ago, and the square root of 4 was an integer, so maybe this one is too. Well, actually, no, it's not. This one can only fall into the real number set, because this gives me a non-repeating, non-terminating decimal. Is actually called an irrational number, so it doesn't even land inside of the Q set. And then we have pi. Pi again is another example of an irrational number, which means it's not an integer divided by an integer. There's no integer divided by another integer that can express the value of pi, which is 3.14 and a whole bunch of other stuff. So that one, but because I can call it 3.14 ... I am able to say that it can be expressed as a decimal, even if it's not an exact decimal. So therefore, it still is a real number. So on that note, that's going to cover off our first of our videos that kind of touches on some of the set stuff. I hope you find this useful, and I'm going to try to do some more of these up for most of the different topics and kind of work through some sample problems for you as you go along. I think that might help you guys out if you get stuck somewhere. So anyway, that's going to be it for now. I should have some more videos ready for you guys in the not too distant future. Bye for now.